All right, so the very last phase of the workshop, and we have an exciting panel with Aniket, Joe, Luis, Kostas, and Alin.
Yeah.
Especially Alin has been so engaged throughout. I think now he has opportunity to really get engaged actively. So Aniket will be the moderator. So over to you, Aniket.
Yeah, thanks a lot. Yeah, so the first one to add, we asked because Don Weaver, whose name we heard so many times in this workshop, we request if he like to join because he was attending the workshop yesterday and today, and he just said yes. So it will be really great to have him as well on the panel to hear interesting things in that space. Can I request everybody to maybe have their videos on if they can? If you can't, that's fine, but it will be good if maybe all the panelists if can have videos on.
Yeah, all the panelists, I think. Just let
Okay.
me stop the
Yeah.
sharing. I think it's better that way.
Okay. Yeah, maybe that will be better. Okay. Yeah. Hello, everybody. Yeah. Thanks a lot for engaging for last 2 days. It's a topic that I find so exciting for last 3 to 4 years. And I found that there is so much to be done and getting done in this space. And that's the reason we thought that this can be a really good workshop to have. We kept this panel only in the end because I hope that we can take this opportunity to discuss the things that we saw throughout the talks and discussions and see if we can talk about some of the interesting challenges and problems that you are already facing when you're building solutions, as well as something that we can look into. That's the thing I wanted to discuss today. So I think you already, all of the people already saw me several times, so I'll leave that part. So let me introduce quickly the panel that we have. I'll go alphabetically. We have Don Beaver, who has an fabulous contributions to cryptography and is currently the VP at Nexus, where he's building cryptographic solutions. We have Joe Bonneau, who has worked on interesting protocols from password security to blockchains, and currently is a assistant professor at NYU as well as a research partner at A16Z Crypto. And I think then we have, oh, sorry, I made mistake. We also have Louis Brandao. No, I think I'm still following correct. Yeah, who is actually working at NIST and is actively involved in the Threshold cryptography project there, as well as the Randomness project. Then we have Kostas, who we all know. He's a founder and has been working in the basically in the cryptography effort at the Mysten lab and SUE. And we have Alin Tomescu, who is the cryptography head at Aptos lab and also one of the part of the founding team. So we have a very exciting panel in front of us. What I want to get it started is that maybe for each of you, you can talk a little bit about what you find interesting in this space in general. And if you're working on some related project, you can talk about that as well in the introductory session. And then we can get started with some key questions. So maybe we can follow the same order. Don, you want to go first?
Sure, no problem. Put me on the spot. This is great. Nice to see many of you friends from before. Hi, Kostas. Hi, Joe, and many other new people and new faces. I'm really happy to jump in here. It's a little last minute, but let me try to just give a couple of quick notions that I think have been of interest and continue to be of interest. For me, coming into the randomness world in the first place was much more about the incredible pain in multi-party protocols of doing broadcast. So Byzantine agreement, find a leader, select the leader at random. But it's clear now that there's actually a much broader spectrum of things you can apply decentralized randomness to, and pretty much any kind of interaction where you want some kind of fairness, it's super important. I think I'm preaching to the choir here. I think it's one of the big, places to work, and not necessarily a challenge, but I guess it is a challenge, is to figure out how we can all come together to come up with standards or levels of interoperability, because I think one of the core aspects of distributed decentralized randomness is that it comes from many different sources. And so if we have 12 different protocols and you have to pick one, you're going to divide the world up into 12 different segments. And I believe this randomness, I believe that randomness. It's much better when we can have them come together. And I think, especially at the outset, the work from NIST is developing along these ways. So I think that will be a pretty strong move for us, because it's a very central piece of blockchain, gaming, and other kinds of interactions. I think some much more theoretical things came up in the chat, and thank you, Alin, for raising them. even issues like how do you deal cards, how do you avoid collusion among players. You can have randomness, but that doesn't mean you don't have cheating going on and you don't have abusive protocols. So I think on the theory side, there's plenty, and it's very mathematical. It's very combinatorial as well. Some of it relates to things like bridge back in the day and extends to poker now, where even though you might say, let's assume people don't collude, there are also ways, even in bridge, of making of broadcasting secrets within the rules of bridge. Like you might bid 2 spades, and in a poker game, you might make a bet that is even if you wanted to communicate with somebody else, and you could actually communicate in the band of the game. So I think there's some very subtle things there that go above randomness to work out and to see whether they're preventable, or to what extent they can't be prevented. I think much more practically speaking, randomness on chains and supported by chains, such as and maybe Mysten and others, that will produce this as a ready-to-go basic material for contracts and protocols to use. I think that's very important. It's hard to backpatch. It's great to see that becoming part of protocols. So no, I guess finally the last one too, which is connected, but it is also a bit of randomness overlapping with zero knowledge proofs, is the notion that randomness in the future isn't just for picking who gets to kick off in a soccer field from what side. It isn't just for cards. It isn't just for NFTs, but it is also a way of showing that you did something before that randomness coin was flipped. So if there are ways, if and how, this is I think a very good general research topic, finding ways so that future randomness, when it is broadcast, incorporates past history in a way that it continues to be random, but also acts as timestamps as well. So linking past and future, these random coin flips can be used as a basic kind of primitive to order and to have causality in the world. So I think that was long, probably long enough. So that's the quick summary of, probably I've overlooked many other details, but I think it's a quick summary of what I think is interesting in this field.
Thanks. Joe, you want to go first?
Sure. Thanks, Don. That was, a lot to think about. I'm not sure I have quite as many points to make. I think I'd say, to me, having spent a lot of time working on this using delay functions, which I noticed seemed like the minority approach, taking the sum of all the work presented here. This distinction between randomness protocols designed to work with an honest majority versus a dishonest majority is pretty interesting. The question I was expecting to get after my talk, which we've debated a little bit, is basically, is there a point to having randomness protocols that survive a dishonest majority when you need a consensus protocol that we know we need an honest majority for? It's cool that we can do randomness protocols with a dishonest majority, but you still need some kind of magic bulletin board for it to really have any value. So I'm interested in this question of the relationship between those two. Is there value for being able to do this and relying on consensus as a black box and building randomness on top, but not trusting the randomness that you could potentially extract from the consensus layer itself, which probably uses randomness? So I'm interested in, I guess, that broad question of like when this is useful, or probably the relationship between randomness for applications built on top of consensus. Should we always just use the randomness that comes from the consensus layer? Or are there social or maybe security reasons to build randomness again at the application layer? But I'll pass to the next speaker with that.
Thanks, Luis. Yeah, please.
Oh, is it me?
Yes.
Okay, thank you. Just a quick reminder on the onset, I'm at NIST as a foreign guest researcher. I'm a contractor from Strativia. Any opinions here are my own and not necessarily NIST perspectives. So thanks again for organizing the workshop and in particular this panel. This is really interesting, and as Aniket just said in the introduction, there's a lot to be done. A few key points maybe that I would like to do here. One is that the consideration of randomness as a service brings awareness about very interesting aspects like public verifiability and auditability of application, often with privacy requirements as well. And so this is naturally of interest in the scope of a standardization body that is interested in the public good. One aspect that I think is of great interest from a technical and social standpoint is that of distribution of trust, which was addressed in many talks, which is also, again, of social importance. And that goal of distribution of trust motivates distributed beacons, as we've heard, again, many solutions in various talks. But that said, also beacon randomness, even if the randomness is produced centrally, it is also useful for distributed protocols. So distribution of trust exists even when we're considering centrally produced randomness. As Don mentioned, for example, possibly the goal of facilitating coordination between many parties. I find interesting that obtaining a random number is conceptually a simple functionality. You want a random number, but we see in practice, like during this workshop, that it creates many challenges whose resolution involves interesting crypto machinery. So that's also one aspect that I think is of interest for me. Generally speaking, I would say for NIST as well. So the exercise of this area of coming up with ways in which we can produce good randomness, verifiable randomness, is likely to require a lot of machinery, which I'm basically saying that the exercise of dealing with randomness is already very useful on its own to develop more greater things in cryptography, what sometimes we call privacy enhancing cryptography, like zero knowledge proofs and others, or more broadly speaking, advanced crypt, etc. One final aspect that is something I find very interesting in this area, and maybe I can later speak a little more into this, is that I find very fascinating the duality between randomness and determinism. And often these are actually two faces of the same coin, if the coin we're talking about is actually where we want to apply this, right? One difficulty of applications is you actually want to produce randomness so that later on you can do everything deterministically and then verify that things were done properly. And I think it is maybe, in my opinion, it's one fundamental challenge in this community, let's say. If we want to really move this forward, I think we need to have killer applications where we're going to have to solve this problem. And that problem of finding a deterministic way of doing things where socially that's not how it's done in practice, I think that's one of the things we need to solve. Anyway, I think that's it for an introduction.
Thanks. Kostas?
I can go next. By the way, I personally learned a lot from this session, like both days. I'm really grateful to be invited here. And thanks everybody for all of the contributions. To tell you the truth, I will go to the more applied section, something that actually puzzles me for the last 2 years, even at the time at Facebook. For different solutions, and we've seen it today, maybe we need different like algorithms. There are situations where you need an oracle. There might be also like algorithms that we have to, even if we have native randomness, for example, Aptos and Supra are working on native randomness on the blockchain. There are situations where you can see many customers coming and say, look, even if you have it, at the moment we rely on Supra or we rely on Chainlink and other places. We have to maintain this like dependency because this is how it works in a cross-blockchain world, right? And sometimes we have to respect this situation. But there are also applications where they want speed, they want different features. And there are even situations where people rely not even having any dependency on committees, including oracles or the validators of the blockchains. And there was a case like very recently where there might be any voting protocol might say, okay, look, I don't trust Saint, I don't trust Sui, I don't trust Aptos, I don't trust all of this stuff. However, I want to use VDFs. And now I heard from Joseph, okay, there are solutions, especially if you have a large scale lottery and other situations where obviously everybody is focusing on deterministic randomness from committees. But if you go to the real world and you play with Web2 companies that are coming to the chain, sometimes they might want something else. And we got from these particular sessions at least 3-4 different cases on how you can generate randomness for Web3 applications. But I would say many Web2 applications are coming to Web3 only for this, because it's very difficult to get this into the Web2 space. And if you want to have transparency, create a new Caesar like gambling system, I mean, a company that you want to compete against the big guys, you need to provide something new, right? And this something new is transparency here. The other thing that I liked is different algorithms here probably provide other properties as well. Timestamping, as like Don mentioned, there might be situations like identity-based encryption. There is like other protocols where you can use on top of this. I would say even AI. I was personally surprised even from Luis, like from NIST, where they said, look, all of these applications are really good. However, in NIST, we're focusing on freshness, on randomness. And if you see all of the committee-based approaches, typically they don't include freshness into the randomness, especially for a short period or even longer period. So you see there are different situations where probably you need different algorithms per case, right? Because there are regulations, there are different like the restrictions and different requirements. Also, I know nobody in this particular session focused on commit reveal. We had only one place where Joe Bonneau had for VDFs. All of the rest were mostly committee-based, I would say. But there are situations where they also need commit reveal, especially for two-player games. For two-player games, we discussed the poker situation. Alin had some very nice comments and feedback there. But for two-player games, maybe you can avoid all of the committees, right? You have two players, they have conflicting interests, and probably you can play with VRFs between them. And now what you can do is you can have a Lightning network, not even a blockchain, people just exchanging very quick randomness between them, and they play all of the casino games, right? You don't need to have any committee anymore. But as you go to multiplayer games, now the situation becomes very complex. I personally learned, like many things, super happy, by the way, I'll go back to my team and discuss about this stuff. There are many optimizations lately. I'm very grateful I was here. And yeah, I have a feeling that after this, there will be protocols on top of the existing protocols that will probably see a combination of committee-based things with VDF, for example, and other cases where we might want it, right, to get two things from both worlds. So yes, that's my comment, and I'm passing the ball. Is it Alin?
Yes, that's good. Yeah.
Yeah.
Thank you, Kostas. Thank you, Aniket, for having me. I also learned a lot, and I'm very happy I was here for the last 2 days. I'm sorry I spammed everyone with 20 questions every day, but I was very engaged by all of the talks and the excellent work. Can you just restate your questions again for the benefit of the audience and also mine? Because I forgot how you framed the question.
So my question was more, what do you find interesting in the randomness space today? What keeps you interested, or in general in this space that you are working on or you like to work on?
Yeah. So for me, I think my fascination with randomness beacons started when I read this paper called COSI about the witnessing service. And I started wondering why use Schnorr and not use BLS. And I quickly realized how efficient BLS is and how easy it is to build randomness beacons from BLS, and nobody's doing it. Now people have been doing it for the last couple of years very well. So I've been fascinated by that approach. I've done some research on scaling such randomness beacons, and I find that approach really intriguing. And more recently, we've thought about that Aptos. We've thought about how to instantiate that approach on a blockchain proof of stake weighted setting and make it scale well. So that's been also very interesting and provided some fascinating, surprising results, like weighted VUFs with constant share size, for example. But at the same time, like, because of the secrecy-based approach to randomness, I'm more and more concerned about collusion attacks. So, for example, Joe just asked, is there any value to having dishonest majority in an honest majority setting? And I think the answer is clearly yes, there is value, because when you consider collusion attacks on all of these secrecy-based approaches, then there's no way to detect collusion. Like, you can do it in hidden, nobody is able to prove that you colluded, right? So it's pretty hard to bootstrap trust in the system unless you have some meaningful collusion prevention. So it's very interesting to me what can be done with VDFs to solve this problem. How can the secrecy-based approach and the delay-based approach be combined together? I think the InstaRand talk today maybe has some insight into that, combining, because it uses a double VRF construction. So one wonders, like, what if one of those was a VDF? Yeah, so I also find that fascinating. I think it's understudied, and for blockchains like Sui and Aptos, who have skin in the game now in secrecy-based approaches, it's very interesting to consider mitigations against collusion. Yeah, and another thing that I'm super fascinated by is Supra is doing this excellent work on Oracle-based randomness for any blockchain, and Sui and Aptos are doing this other work for instant on-chain randomness to smart contracts. And for our line of work, I think some interesting complications arise that don't arise in Supra's line of work. And one interesting such complication is this undergassing attack, which is like when you give smart contracts instant access to randomness, imagine you flip a coin and then you branch on the flipped coin like you do an if statement, right? You have two execution paths. One is low gas, another one is high gas. You can always ensure that the high gas path is never taken by undergassing your transaction, paying less gas. And you'll just submit this transaction, it gets aborted every time the high gas path is taken, and then only the low gas path will be executed. This is actually an attack pointed out to us by Valeria Nikolenko at A16Z. And Joe and others. So yeah, this is really concerning because it makes the APIs kind of subtle to use. there is a simple mitigation against it, and maybe we'll discuss it later, but all of these types of new novel attacks that we haven't thought before as a community are very interesting to me. And I'll leave it at that.
Indeed, maybe then we can go into indeed all these topics in bit more detail. Right? So for this adaptation, it's very interesting, right? Because it's also relevant in other cases, but less so because the randomness gets fixed. If you look at the current Supra or chain-link approaches, the randomness gets fixed. So even if a transaction does not change, because the request transaction is already fixed, so the randomness gets fixed. So the idea is to just put more gas and submit it again, which can't happen. I can certainly see in the Aptos case, because the randomness is already used. So very interesting thing this, but it's also preventing other case, but the two transaction help us there because the request transaction already fixed the randomness in general. Yeah, quite interesting. So go ahead.
So the and reveal pattern with two transactions. That's one simple defense. For Aptos, for SUI, you just pick the randomness in one transaction and then consume it in another and you're good, but that creates more friction.
Yeah, how to build even that in a smart contract could be challenged, right? Because you have to make sure to use that old randomness then, right?
It's
Where
pretty
the
simple. I can even show an example. It's still developer unfriendly. Developers have to be aware of the attack, and most developers won't be, and they'll just branch on the randomness. It's a problem.
Yeah. Just to add from, we did a video. Go ahead, somebody was.
Oh yeah. Sorry, I didn't need to interrupt rudely like that. I was going to make a comment too. Partly, I'm going to use marbles in two different ways. One is I lost my marbles because there was a bullet point that I forgot to mention. I had it sketched down. But second is that what Alin is talking about is essentially take your marbles and go home idiom in English, which is I just quit. And we all know this in the randomness world, that you can see what the coin flip is and then just say, I don't like it. I quit, I go home, and there's a consequence to it. So various different kinds of mitigations of that, but just overall, I wanted to mention, and you guys were just mentioning it in the framework of gas. I was hoping that somebody would actually jump in with this viewpoint, but overall, the game theory and the economic theory of using the randomness, and essentially, in part, it can concretely be done through stake bonding. If you enter into a game and you go home with your marbles, you lose your stake. It's almost like poker having an ante at the game as well, but that's a little slightly different motivated. But really express studies into what the impact in game theory is of the option you always have to leave. It's a built-in economic option to leave the game. And so if you can phrase it in different ways, one is just quitting. The other is this: it's free to me to avoid the high gas cost path that Alin was saying. It's an option to take this path or that path. And it all goes back to the deterministic randomness. I'm going to unwind and prove at every step that I have done what I committed to in advance. If you're completely deterministic, that avoids the branching opportunities. But if it's not built into the chain, if it's not built into the built-in cost or something like that, you will get this branching in other ways to subvert it. So I think that framing it in terms of costs and expectations and game theory is a much broader way of looking at these things when they apply to blockchains as well. And it gets back to incentive theory too. And that also would be, I think, a very ripe field to study. And I think people are. So that was just an add-on comment.
What I would add to that, Don, is it's when you have economic incentives that can motivate people to finish protocols, reveal things, whatever, that can really help. But we should almost draw the distinction between randomness protocols that are used for one specific game or something, where you have some hope of estimating the economics of what people have to gain by manipulating it, versus a lot of the talks and discussions are assuming we're building a randomness beacon as a public good. You have no idea who's using it or for what, in which case it's very hard to really estimate how much money is on the line and how big the penalty you need to actually keep people honest.
The same applies to all of the committees, right? We have committees giving randomness. However, because you don't know in what lottery someone is using this randomness, it might be a international lottery of billions, right? And your stake is only a few millions. Now, do you have an incentive?
You can't even really estimate it by looking at the chain, because you might be lottering, and there might be a lottery for an NFT or something whose value is impossible to determine simply, and then you really don't know.
So just one advantage of committee-based approach, just to complete the thought, is that we can make sure that every request has its own answer, which is unique. At least in the random oracle space, that could be easy to do. by appropriately hashing that with the inputs that are specific to that question, and that can mitigate at least to some aspect, this aspect where you do not have any idea how much is the value at stake with respect to the correctness or unpredictability and biasability of the randomness.
But liveness, you can stop liveness though, right?
Yeah,
In
liveness
the
is
worst
always
case, you might decide to stop. Okay, I'm not running it because I know it will be against me. Yeah, correctness is fine. I agree.
Yeah. Cool. Yeah, very interesting. This under gas attack is quite interesting. So the thing I want to ask is something that Alin also mentioned and came up in Joe's talk regarding this dishonest majority VDF-based solution. And there I have a two-part question where Joe, you can start and others can chime in. The one part I see is that indeed that requires good understanding of VDF. Are we there with understanding the what are the good parameters to run for VDF by now, so that we know that these are the best ASICs with circuits, so we can precisely understand that, and this is how much it's going to cost. That's a part one. And my part two is that when I look at all these protocols, I see that there is an inherent synchrony/broadcast channel assumption, which can be challenging in blockchains where they're front running or all sort of this reordering attacks, to say the least, or in general asynchronous there. So am I right to see that the synchrony is somehow inherent there, or it's just that you think that is solvable?
Yes, maybe I'll do the second question first because I think it's like a little bit easier. I think most practical blockchains have a close enough approximation of synchrony with some maximum delay that, that I think the delay-based approach can survive that problem by just making the delay a little bit longer to the point that you're sure people have time to broadcast and consensus can happen. I think, in theory, it's quite interesting. And could you do anything with delay functions in a partial synchrony model? I think with full asynchrony, it's hopeless because somebody could always wait out the time the delay function takes. So yeah, theoretically, I think there's probably a lot of work that could be done. In practice, I'm at least personally, somewhat comfortable that you can get the timing right. The first question about ASICs, I think we're probably still not quite there yet. The ETH Foundation did a lot of work on the Minroot project. It got deprioritized because of some cryptanalytic attacks that are possible against it. I still think the repeated squaring approach is pretty good. Maybe the right next step would be class group based repeated squaring VDFs and hardware for that, but we might be a few years away. Chia has deployed it for years, so I think there is some track record. But I think we're not quite there where I'd want to put it in production tomorrow for $1 billion lottery. The other quick note I wanted to say about, I've been trying to say delay functions. I think we knew for a long time, you don't really need a verifiable delay function. It's nice, it makes the protocol better, but it's not really essential. And you can even build randomness protocols from weaker assumptions too. There's things with time commitments, and you can even use kind of special purpose time commitments. Not a huge difference. We know how to build VDFs, but you don't actually need the full VDF functionality to do this. I guess it's an open question exactly how weak of an object you need, but
I think the synchrony question is really interesting because the main reason we went for the secrecy-based approach is because we couldn't see a way of making the VDF delay-based approach work as fast as our consensus algorithm, which is to be responsive, like Aditya defined it in his talk, which is randomness is produced as fast as the network proceeds, right? That's a really nice research problem that the community could study. It'd be interesting to either prove impossibilities or just explore.
I
So
don't
we
believe
did
it will. Yeah, go ahead, Joe.
Yeah, I'm not super hopeful. We did write a paper called Bicorn that does a delay-based beacon, and if everybody's honest, you get the result right away.
But we looked at that we couldn't find a way to make that work. We can discuss.
Yeah, the delay function's like a fallback in that case, but the problem is, you need everybody to be honest to get the fast output.
Which would never happen in the fast path.
Yeah, it depends how small your committee is, but there might also be, this is something we didn't really explore, but there might be some other hybrids of Bicorn where you don't have a full dishonest N-1 security, but you have some slightly lower threshold, and then you can recover the results quickly without the delay function with a smaller group.
Okay.
It could be
Okay.
like, yeah, you assume at most like F malicious nodes, which could be a majority. It could be a dishonest majority, but not like a dishonest super majority. And then you get the fast result as long as you are far away from that.
Another line of research I've seen in the past is people are using enclaves for VDFs. So it cannot be run in another hardware.
Yeah.
And now you can limit it as much as you want. Obviously, you cannot be as fast as the super fast consensus algorithms at the moment, again, right? Because you have to give some period for the seed of the VDF to be broadcasted.
Yeah. My question with that approach is what the advantage is over just doing a TE-based protocol, right?
Maybe you get something from both worlds, right? One is there is a minimum time anyway, even if you had a more optimized feature of this, but at the same time, you also get the, I don't know, are you thinking about committees over SGX, over TEs or something else?
Yeah, I don't know. Just to take any honest majority protocol and have all the participants be TEs, right?
That's true, but in this particular case, you only need one.
Yeah.
That's the main benefit, right? You don't need to synchronize the answers and get a K out of n result. That's a benefit.
Yeah, but then that's fragile because if the one TE goes down, then someone can manipulate the whole thing.
True.
I think these are
Okay.
interesting to strengthen or bolster existing things, but one of my friends was one of the authors on that paper that broke SGX, and I've never trusted it since because I was next to
Yeah,
him.
you have to be more specific about the paper that broke SGX. It's 10 different papers, but
The 2018 one, yeah.
No, pretty fascinating. I'll just put it that I find that if you can make the VDF approach working partially, I find that to be very interesting. I haven't looked into that, but that could be interesting to prove either way, right? So quite fascinating in general. Then I want to, so maybe Kostas, I know we are very close to also the applications getting built with the cryptographic intention and so what kind of interesting, did you come out some interesting applications recently that, hey, here we suggested to use randomness or we could use randomness and something that you got excited about? Yeah.
Of course. Obviously, we all know that like any gaming application, where in gaming, randomness is pretty much the most dominant factor in modern society. That's the reality. Even on chess, if you play with white or black, you have an advantage. So again, there are situations where randomness is required almost everywhere in our life. There are even like investment schemes in the UK, for example, where you are investing in bonds and something, and with some probability you are getting your money back or your investment. So it's not only gaming. Some other interesting applications, especially with BLS schemes, is obviously time capsules, right? If you can use a public key as an identity-based key, in practice, you can encrypt messages to the future, and all of the applications that are using just rounds, you can have a clock, and then eventually this clock is revealing the secrets for the time encrypted like content. Something else that I personally realized very recently is the use of randomness on AI. And many people are saying, okay, let's use AI. I've also seen like even Ari Jewels, who is working on like oracles that they provide probably AI responses on the blockchain, because obviously doing all of the AI on chain might be a bit expensive. A small thing that people didn't focus on is how the AI response, even if you have a known model, is seeded. What's the seed to the AI? So you have a deterministic result, right? Because people can play. I can ask ChatGPT 10 different times, and 10 different times I can get different results. So in practice, what we need is to also be able to seed all of the AI models with something, probably out of these solutions that we're proposing here, where the output of AI is deterministic. Because otherwise, imagine you're using this for a new CryptoKitties and you want AI CryptoKitties, but the response has to come from an expensive model. How? You need to seed it with something that was an output of the randomness, and then you know that the result is deterministic from the AI. Otherwise, the AI is not necessarily helpful because it's also non-deterministic. So we will see determinism. I think Luis mentioned previously, right? Determinism is a very important feature of all of the work that we're doing in randomness. Randomness is actually one of the tools that we have for determinism, especially if it's verifiable and we know it can be a seed to any non-deterministic algorithm. So definitely these three places where you see it. Obviously, we see it on like leader election and other things inside consensus. But I personally can imagine many applications now that it's easier to have randomness on chain to emerge and actually provide more interesting features for the users. As I said before, gaming, AI CryptoKitties, investments with some randomness element, even MEV protection and other things might also require some randomness. There are many situations, I believe, that we haven't thought originally. And after you have this vehicle on chain, maybe like you can see startups emerging, oh, now we have randomness on chain, I can propose something else that was not possible on Ethereum and Bitcoin before. So yes, that's a short answer. And I believe after this session, there will be 20, 30 applications of randomness outside gambling. Because gambling is the first thing, lotteries, that someone is thinking about randomness. But it's not that anymore. It's a lot more.
Somebody else want to add on to what they find interesting, or I don't know, did you find some interesting applications for the Aptos role that people that you
yeah.
got people interested to work on?
So we hosted a randomness hackathon, and I think the winning participants were these folks called Zion Bets. And they had this really addicting game. Like, all of us were having so much fun in the office playing this game. It was like, predict when some price is going to crash. Like, some price would go up and predict when it's going to crash. And it was super fun, super engaging, and made trustworthy and verifiable via on-chain randomness. So I found that pretty cool. Like, that was what I was hoping we get out of this hackathon is see something surprising being built. And that was one of it. Because otherwise you can think of simpler things like roll some dice, lotteries, do a raffle, but this was creative. Yeah, so that's my top choice.
Yeah, one more thing that I was curious to know that from Lewis is that I know that NIST has the interoperable randomness projects and threshold cryptography projects. So what kind of plan is emerging there, or how will things look like? What's your vision for 5 years from here for projects like these? Because both of those projects are quite interesting from the community perspective, the distributed threshold cryptography project, as well as the interoperable randomness project.
Thank you for the question, Aniket. I guess I should start just with a little bit of a very brief context. So this project emerged in 2011, and it was seen essentially as a way of promoting public randomness as a public utility or public good, and to motivate the community to consider applications, alternatives, etc. And so in that sense, it's very nice to see that the community is very interested in randomness beacons. Of course, not only because of the NIST project. And also in terms of context, initially this project emerged at NIST also with a component of actually physics research in terms of developing quantum random number generation and some certifiability aspects of it, seems like Bell inequalities, etc. And so, for example, the NIST beacon today actually uses a quantum random number generator, among a few others, built by the physics lab at NIST. Another point of context that to connect a little bit to the vision, namely in terms of continuation, is that it's actually institutionally challenging to commit resources to maintain active a beacon in the long run. So in terms of vision, we hope that the project can actually continue in the long term. Now, in terms of actually things that we would like to see developed, one obvious one is to actually conclude the revision of the current reference, which is still in the draft mode for the past 5 years. So we're going to have a few adjustments, hopefully by the end of this year, but it's difficult to promise. One thing in terms of vision, globally speaking, relates to motivating the development and the deployment of secure randomness beacons across the world. So there's one interesting concept, which we actually we mentioned at some point in our reference, which is this notion of Schelling point, which is like, what is the solution that people may look for in the absence of coordination, of asking other people around? So there's many problems that emerge everywhere, like how do you do a lottery? How do you select a committee of people for something that might be of national interest? And so one question we pose is, what do countries do at a national level? For example, should there be some sort of randomness beacon per country? Or this beacon can be either like NIST or a league or something like that. But in terms of vision, in terms of progressing the use of public randomness as a public good, it would actually be nice that we reach a point where countries, national bodies, recognize the need of public randomness to solve some problems. So it would be very interesting that we have this progression where eventually countries recognize the need of randomness beacons as some infrastructure. And again, that could be randomness on chain as well. Maybe they recognize that there's a blockchain that is the default one for the country, and that's how they use it. Just to mention one different aspect that I think has not been mentioned at any time in this workshop, which is also part of the project at NIST beyond our actual implementation of a beacon, is the actual research on the development of secure randomness. And one very interesting area of research is the area of publicly certifiable random numbers. And it looks like it's a bit missing the term. Sorry, I'm missing the term. It's a bit far-fetched idea, but it's something very akin to what do you call quantum supremacy, building randomness out of a quantum computer with a quantum process that allows people to check that string necessarily contains fresh entropy. It's a very interesting problem. There are conceptual solutions for it. There are some proposals, but they're really not that feasible. But this is going to be something in the future. So I highly recommend looking at that. Publicly certifiable quantum random number generation. Just to wrap up and just mention a few topics. Again, I think that promoting the actual use in applications of social interest is very important. So as a vision for the project, I would see it would be very nice if the community continues getting together, but eventually we reach a point where we're actually discussing actual applications that are happening across the world. And I think it would be nice from a community perspective that because we have so many solutions currently, so many proposals for randomness, it would be nice that these fancy ideas of how to get public randomness could actually be then used as a motivation across many beacons. So I think we can find some synergy there. Yeah, maybe just speaking on an extra point along the line of what Kostas was saying, that different problems may require different solutions. I think it would be interesting to see some advance in documentation towards some kind of taxonomy of verifiable randomness. Not only, of course, we heard during this workshop, you have centralized production of randomness, decentralized. That's one aspect of taxonomy, but it would be very interesting to have a more detailed taxonomy where people can understand what are the actual properties that you're getting from each type of solution. And I think, again, that would be interesting to promote verifiable randomness. Just to finish, because I don't know if sorry.
I just wanted to add one thing. There have been, I wrote one of them with students. There have been 3 SOK, Systemization of Knowledge papers on distributed randomness beacons in the last 2 or 3 years. So there have been, I don't think we quite have a full taxonomy of everything, but there have been some attempts to have nice papers that lay out all the protocols and properties and things. So
maybe I'll just finish with a pun that I saw while I was during the workshop that I found interesting. So we heard a lot about random beacons, and at some point I was looking at it. We have so many beacons that at some point when we talk about random beacons, it looks like we're selecting a beacon at random. So it might be interesting to differentiate between random beacons and randomness beacons. Anyway, just to finish on a funny note.
Luis, can I ask a quick question? Is NIST interested on post-quantum randomness in general, or you would accept any kind of randomness at the moment?
I mean, we're certainly interested in anything post-quantum. I'm not sure if you're asking from a perspective of inserting something into the reference we have for randomness beacons, or
Yes,
if you're just
that's
asking
the question.
In general,
That's the question.
yes.
Yeah, that's the question.
I would say yes, but let me mention one technical challenge. For example, in our current architecture, we have a difficulty where we need the signature to be deterministic. So if you want something post-quantum, you need to come up with a good post-quantum, verifiably deterministic signature. And of course, we also need to use any standardized signatures. It would be interesting to consider it from a standardization perspective. But the general answer is yes. And in particular, the reference we have is not just for us, it's for others to use. You know, it's not inconceivable that people would use the NIST reference if they like that model, but then they would actually use a different signature in this case. So if you have post-quantum solutions that NIST is not following because they're not standardized, it doesn't mean that it's not interesting. So it's certainly interesting.
Okay.
Feel free to have some concrete idea.
Sorry, go ahead.
Yeah, no, a quick, since randomness versus random and terminology, I think is an important thing to think of. I've always hated the word post-quantum. And now Kostas is asking a question about post-quantum, and that is, security against quantum-enabled computers, and we all know about that. But specifically, you just mentioned the use of quantum computers. So it is quantum-enabled as a different branch of how do we get randomness. And some of that goes into, oh gosh, we have Heisenberg uncertainty, Schrodinger cats and stuff, the things everybody knows about quantum, producing randomness. Some of that is non-local. Like I could have a protocol that is operated on the moon to the Earth, and then I can somehow prove something was random because they're separated by distance. So there are a lot of things that you could do with physics, non-locality, quantum, etc., that you could produce randomness with if you have the technology. But there's no need that there's no way of saying we're going to get quantum computers that can break cryptography systems at the same time we'll get quantum computers that will enable useful things. So I think being very clear on what it is that NIST is seeking, and just all of us in general, are we trying to be secure against weaker crypto systems, or are we trying to just assume we have really awesome tools? I think that's going to be really important, especially if you start trying to standardize or offer solutions, because I'm sure there are plenty of people who would love to go and start thinking about, physical or quantum-based solutions to things using machines that won't exist for 100 years, or maybe using machines that exist already. But I think that's part of a goal here too. And also to address what Joe was saying too, SOK is fantastic. I think the understanding of this very diverse set of applications, it's shocking to all of us. We suddenly realize, oh, there's 16 different properties, and when we're using it for consensus versus whether we're using it for a lottery, it's even mind-blowing to those of us who are specialists, if you like, in the field. What is that going to look like to people who are playing poker, or who are just saying that this poker company is honest because they use deterministic randomness? How do you even say deterministic randomness to somebody without having a laugh in your face? So we need good explanations of what these things are, because they're very subtle concepts in there. So ergonomics for developers, understanding for developers and people who want confidence in the system, good terminology, I think are really important to keep emphasizing, driving towards. That was it.
I love terminology. I agree. I also want to follow up with, because you mentioned you want to have a quantum generator of randomness that is verifiable. What would be the ground truth that you verified that against? Would there be a post-quantum public key or something of that sort? How would that even work?
Without entering an additional intricacy, it's something intuitively, it's something whereby you do a computation that you can prove could have not been done classically. You had to harness the quantum computer, and then you can verify faster than what you would do the computation. You can verify, indeed, I would have not been able to do this classically. And then you know that the way in which you compute that quantumly inherently uses randomness. So it doesn't mean that the full string you get is a uniform bit, but it means that in this big string you get, you know that there's a certain amount of randomness. There's some additional intricacies where you might actually have to have a seed to start with to define the problem that you are actually computing the solution for. But essentially, it's something related to quantum supremacy. You can prove that something could have only been produced with a quantum computer, and therefore it inherently includes entropy. And then you can hash it, and then you have enough entropy there. It's very interesting.
Yeah, sweet. I guess unbiasability would have to be taken care of, but sounds really sweet. Yeah.
Yes. Maybe you can add an PDF for unbiasability purposes.
Yeah, but then we'll require the VDF with the post-quantum property. But yeah, so quite fascinating. I want to make sure that, so I also have more questions to ask, but I want to make sure that at least some of the audience also get opportunity to ask questions. So maybe you can type questions and then we can look into, or maybe some of them might be already on Pratesh.
So Q&A, there are a couple of questions. I think one of them was for previous one. So let me and there are 2 questions for this panel. So do you want me to read? So
where are you looking at in the open questions you mean?
Yeah, so it's mean root analysis to Ethereum. I'm not sure if it's relevant to this panel, but this
So
just
probably.
posted. Oh, I see. It's
Okay.
different. So Amit was saying something about reference for random generation using quantum device. So there was one paper.
Okay.
I see. No, I do not
Yeah.
see more
Yeah, thanks
questions.
for Yeah, so are there, I mean, we still have maybe around 5 minutes. Are there some questions that somebody want to ask for the talks or the discussion that we're just having? Please, maybe you can raise your hand and we can try to put you on the panel to ask immediately.
Yeah, I was maybe like wondering
Yeah, go
about, I can maybe at least like slightly involved because we spend a lot of time at Supra wondering about this cost optimization, right? Like how to somehow derive multiple randomnesses from a single seed where because things are transparent, things get exposed immediately. And so Instaland is one of the examples. So I want to see everyone's perspective on the thoughts because this was like motivated from the client's end where they complain often about the cost they had to pay for any of the services. I think Chainlink is probably one of the biggest provider in this space, and a lot of the experiences they have. I don't know if anyone can take that question. Do you have any idea about the experience, about the gas cost or overall cost amortizations?
Yeah, gas cost and latency, I think.
Latency as well, yeah, like
as
both
well.
costs. Yeah, you're right. Yeah.
Maybe I'm not understanding the question. Are you asking?
The thing is that if you use this, let's say, I don't know, like Chainlink service or Supra, so we provide this randomness service for a fee. And
Yeah.
then typically it's one of the reasons that people do not use as often for like Web3 gaming, that they are not that cheap actually. So
Right.
they have to pay significant amount to get, let's say, one random seed or something, right? So like for example, Aptos role has this again, like it probably doesn't apply to Aptos role because you're not acting as service provider to other chains. So maybe more applicable to those where they're providing service, but it's maybe more from the other side, like from the gaming side, it's more relevant, this question. I'm not sure if you ever encountered these or if you have any experience, or we can just
Yeah, there is one question that can be relevant for both of them, for Kostas and Alin. Let's say the moment you think you are generating on-chain randomness at the end of consensus process, you are adding some latency. You mentioned this 20 millisecond when I asked. Probably I think same thing, it should be similar like that. I would think at least maybe the new optimization that probably you're mentioning it will become less because currently you add one more message delay. You add delay, one more additional delay, right? You have to have commit and then commit certificates are getting signed. So it should be around 400 milliseconds or stuff like that. And computation time on top of that, right? For example, if you're working with 1,000 shares, it's a significant computation overhead, right? How much was the difference?
So for us, the computational overhead during VUF aggregation, if I recall correctly, is on the order of 100 millisecond or something like that. The latency in the consensus is a message delay, I want to say. I wish Daniel was here because he would know exactly. And we're working on it of getting randomness to play better with consensus, but it's like it doesn't really affect our bottom line consensus latency much. We're still under 1 second per block. So we're pretty happy.
Yeah, I'd like to know from Kostas, I don't know if you already have something number to share, but one part there is that unless then there is the randomness user in every block, sometimes it can be you're still producing that even when you do not have somebody making a randomness request, right?
request. Yeah.
Did that play a role in the question? Did that came in discussion?
Yeah, it did. And we're thinking about some consensus optimizations that might not play well with randomness, right? And there may be ways to make them play better by doing exactly what you're saying, observing that some blocks don't need randomness. So yeah, we're discussing things like this. Yeah, I think the trade-off is worth it though. Adding a little bit of delay to your consensus, let's say you go from 600 milliseconds to 900 milliseconds, is totally worth it for the amazing flexibility that you give contract developers. But that's obviously a decision every blockchain should make on its own.
There are also other optimizations we can do, right? Down the road, I don't believe cryptography will be the bottleneck anymore of any blockchain. As we go to multi-machine validators, you don't care about this stuff because it's stateless. Right? So eventually, even in the future, I have a feeling that any crypto stuff on the blockchain eventually will contribute almost zero to latency.
Yes. Okay. That's encouraging.
Yeah, probably because we are running over the time.
Yeah, we can probably wrap it up like any
Yeah,
closing
yeah.
remarks or something. Yeah.
Indeed. So what can be nice in the end that if each of you, can you just quickly talk about what was the takeaway for you from this 2-day workshop that you're taking, so that even that you are excited to work on, or this is what I understood from 2 days. So a short summary from each of you will be nice. Maybe this time we'll go in our other orders. Maybe Alin, you want to start?
I bookmarked a lot of papers while people were presenting. I think I have several papers on this exponent VRF stuff, which I've been meaning to look into, but now there's been more motivation in the talks. And I have more randomness beacon papers from all of this work. Like I want to look at Instarand and understand better what it does. Yeah, just really my goal is to follow up on all the presentations in more detail.
So anything we can improve on, that's also I want to ask with this workshop management. I guess the Q&A, this thing was like logistic was a bit of mess up. Sorry about it.
Yeah,
Shall I go next? So I already sent.
Please.
I already sent papers to our Slack for the team to actually explore. Something that will actually help is on all of the presentations we have, probably even on the agenda. If we know there is a white paper, let's have it on the agenda, because otherwise we have to look, right? And now people are asking, oh, did you take a screenshot of this paper? And maybe I didn't get the screenshot and I need to find it somewhere else. But yeah, I personally loved it. Actually, it was higher quality than I expected because it happened at the very last moment. And I didn't expect even Don, the fact that Don is here in the very last moment is very useful, right? Because he's adding some perspective of what happened in the past that I didn't have knowledge about it. I was not even born.
None of us were.
Yeah. Now,
Thanks for making me feel so old, Kostas. I appreciate it.
No, even the Strobe
he's trying to
paper
feel
with,
that he's younger.
I'm telling you, even on the Strobe paper, the paper with the history, like regeneration, without Don, we couldn't do it. That's the reality, right? Because there was some information somehow lost in the progress of cryptographic schemes. Yeah.
It's me. So I guess one takeaway, I guess I'm going to be a bit more high level than identifying specific talks. One takeaway is that it's very nice to see how active this area is in terms of research, which does hint that there's much more still to come. And this basically makes me think that there's still also a lot of synergies to explore between different solution approaches. And just picking a bit on the words again, we hear a lot about on-chain, off-chain, and that makes me think, if I'm thinking from the perspective of beacons, it makes me think also of on-beacon versus off-beacon. So for example, again, we heard a lot about delay functions, etc. There's no issue in using that type of gadget on top of something that is produced by a beacon. Maybe I'm a little self-centered here, thinking about the NIST reference, because somehow I feel that it also is a bit an outsider as compared to much of what we heard here. But from what I've heard during the workshop, I think, okay, a lot of these ideas are actually really cool. And I don't see that there's an inherent prevention that many of these ideas could be used alongside with the randomness that might be built by a national beacon. So I think that's an interesting idea. And generically speaking, this applies also to, I think it would be very interesting to further explore interconnection of beacons, how beacons can use other beacons' outputs as their own input to possibly facilitate assurances of freshness and other aspects. So yeah, the generic comment is great to see all this energy put into this area. And I think there's a lot to be developed. And just to, again, emphasize this point, I really think that a major challenge that there is in this area is in getting social acceptance on public randomness. And that does require a work that goes beyond the actual generation of randomness. It goes into actually making these applications real and acceptable.
Yeah, that's wonderful. Yeah.
Joe?
Sure, yeah. I think after seeing this and the variety, I'm probably most interested to learn more about combining different things, hybrids between delay model and committee-based things. So I think I'm going to think more about that and try to think about what the limits are.
All right. Don, you want to?
Oh, I get to go first and last. This is really cool.
Yeah.
Quick takeaway. So one on the workshop itself, logistics. I think everything was great. I was really happy to come to this. I only heard about it last minute, kind of what Kostas was saying. And I think so getting the word out is important. That would be a bigger step. I was amazed when I dropped in. I'm very used to people saying randomness beacon. What are you talking about? Why do you need a beacon? And so seeing that this crowd is actually is the crowd of strong investigators and followers was also extremely encouraging. And so I'm really excited to see the amount of energy being put into this in so many different avenues. It's really refreshing. And I actually felt almost redundant at some point saying things that everybody knew already. So this is exciting. Keep it going, please. And onto the topic I mentioned a little earlier, the ergonomics and public facing. I want to reiterate what Luis just said, making sure that people can understand what is going on here, why it's important. I think in the United States, when you have the Super Bowl and somebody flips a coin to start the game, to see who kicks off, you need that kind of understanding about what it is and why we're doing this, because that's what makes it important. That's what builds trust among people when they understand why. In terms of the actual sort of technical side of this, I as well, this Exponent VRT is awesome. 2024 papers are great to see coming out. So I'm going to dive into that. I really like a lot of the investigations, several groups going into essentially the L2s of randomness. What can you do to generate some expensive randomness to begin with? And then, as Aniket was saying, also make it cheaper. Right? Maybe you go offline with that and generate and use it offline and then come back to a chain. So ways to scale so that it's not $15 to play a game. So it's much cheaper. Of course, that's going to be fun for the people trying to make money off of this, to monetize this as a balance. How do you keep the servers going, as Luis was saying, and how do the companies here keep the servers going without just giving away everything for free? That's also an interesting, deep technical question as well to think about, I think. So yeah, I think that's great. The social acceptance, I think, is huge. So that's really the remark I would end with.
Yeah, thanks a lot for really nice discussion. I enjoyed a lot and also learned a lot in the last 2 days as well as from this discussion of that we had. So just for the everybody, we have recorded these sessions and we will try to cut the talks appropriately and make it available so that then it can be followed up also later. Those, if you want to look at that applies to the panelists as well as for people who are involved in general. All right, I guess with that, then we can finish the section. I'll get it back to Prate. You want to say something in the end? And
No, it's been, sorry, you wanted to finish off.
so go ahead. In case I know that some of you have possibly have meetings starting already because we are running little late. Please feel free to.
Feel free to leave. So I guess it's been really wonderful organizing this. Now I'm more excited to delve more into these topics. A lot of the beacons, for example, I really knew from a very overview, and now that I should really go deeper. It's really having Dawn attending all the session. It's big thing actually. So far I've been only writing beaver triple. Now we have a real beaver. So this funny, I was talking to Rohit and he was like, lot of this Git commit has beaver thing, updated beaver. So it's funny anyway. All right, so it's really great, and we hope to really make these something more regular. This is the first attempt, and I hope this community grows. And especially one of the thing that came out of this panel was Luis actually talked about, also everyone else standing, was this policy aspects. Actually, recently I was giving a talk in one of the IITs, and then I started with an example that even if this property land allotment that happens where I live in right now in India, is a lot of random things are happening, and people are skeptical about whether they're actually random or they're already somewhat manipulated. So I know this is a very long shot. Convincing the government to changing policy and making them understand the technology is a huge deal. We've got to start somewhere. So it's really great to have all these technical and non-technical aspects as well. So with that, actually, I would like to just wrap up.